Hello there, Cougar Academy, and welcome to Lesson 6.6, Part 1 on synthetic polynomial division. Last time, we used long division to divide polynomials. This time around, it's a little shorter method that we'll use that hopefully you'll come to find is pretty nice. So, a few key things with this one as we begin is that you can only use it if we are dividing by v to the first power. Okay, so if it's something v to the first power, then you can use it, which for the examples I'll give you, that's the only type you'll have. So setting it up is pretty similar, only we are just going to be concerned with the coefficients of v to the third, of negative 2b squared, of the negative 28, and also the negative 59. So we just want those coefficients. We're taking the letters out. That should excite some of you guys. And then what we write out front, here's the first little curveball, is if we're dividing by negative 7 or v minus 7, we're going to put a positive 7 out front. So that is the only one of the only curveballs for today, is that we're putting the opposite of the factor we're dividing by, or the piece. Okay. After that, it's a nice little process. So once you do it a few times, it becomes pretty quick. The first step is to bring down the 1. So bring it on down, or the first number. It may not be 1. Then you are going to multiply. And we multiply the 1 by the 7 that's out front. 1 times 7 is 7. And then we add from the column. So notice I put the 7 below the negative 2. 1 times 7 is 7. We're going to add that column together, and then we're going to repeat until we can't repeat anymore. Repeat. Okay? 5 times 7. So 5 times the number out front, 7, is 35. And then we're going to subtract those, negative 28 plus 35. Is just 7, and 7 times 7 is 49. Add those together, and that gives us negative 10. So our answer, it's pretty much here. It's just hard to kind of see what's going on. This last number is always your remainder. So this last part is always the remainder. Always. Okay? These other parts are actually a polynomial of sorts. The 1 corresponds to a 1x squared, or v squared, I suppose. The 5 corresponds to a 5v, and the 7 is our constant. So let's see, and let's also write a remainder, or minus 7. Remember, that's how we properly write the remainder. Let's see what happened again. So we start with v squared because it is 1 less than v to the third. Okay, since we divided by a v to the first, putting all these pieces together means the next term would be v squared. And then it just goes down order from your degree. So v squared, v to the first, v to the 0, which is just 1, or our constant. So that is your final answer. Okay, remainder and all, v squared, v, and so forth. Okay, let's check out another example, practice this skill a little bit more. Number 2 here has another little curveball, and remember with the regular division that you want to make sure you have all of the variables accounted for, and we're missing of x to the first. So we fill in that gap with a 0. So as we write our coefficients, it's going to be 3 for the 3x squared, negative 18, 0 for the x, and then negative 4. Out front, we're going to put a positive 6, because again, it's opposite of our divisor. Let's remember our steps. Okay, bring on down the 3. 3 times 6 is 18. Add those columns together. 18 plus negative 18 is 0. So that's pretty nifty. 0 times 6 is 0. And that's 0 again. And 0 times 6 is 0. When we add those, it's negative 4. So a few things happen here to point out. Again, negative 4 is our remainder. So we can already add our remainder in there, negative 4 over x minus 6. these other pieces, it can be a little tricky. So this represents 3x squared. There is nothing that goes with the x. There's 0 there, and there's no constant. So it's really just 3x squared plus our remainder. That is the answer. So you could get coefficients of 0, which essentially just knock that term out. So the orange box there, or yellow box, highlights the answer. So don't be afraid if things cancel, but be careful with your arithmetic. Okay? What we're going to end up doing is actually solving through these. And the key thing with solving, if you remember, remainder of 0 means factor. So we're going to check this number 3 here to see, is v plus 6 a factor of this polynomial? We check that with polynomial division and quickly with synthetic division. Okay, so this time a negative 6 goes out front because that's the opposite. We bring the 1 down. 1 times negative 6 is negative 6. 10 plus negative 6 is 4. 6 times 4, negative 6 times 4 is negative 24. Combine those, then we get 12. And little happy dance I like to do, yay, because we have a factor or a remainder of 0, which means this is a factor. Woo. Okay, now properly writing this out with our variables, I keep wanting to put x, it's a v. V to the second power plus 4v minus 2, that would be the other factor for this particular polynomial. Okay, so it is a factor. This stuff would be the other factor. In the future, we'll end up solving that, but that's it for now. Okay, so factors have remainders of 0. Here's number 4. Okay, I encourage you, pause the video, try it out on your own, see if you get the answer. Okay, I will go through it, and you can check your work at the end. If you need help with the setup, and then you want to get started, you can do that. I'm going to tackle it right now. The more you do these, the quicker you will get, and it makes it pretty nice, you'll come to find, with division. Okay, be careful with the signs. A few times I mixed up the signs there, but I fixed it in the end. So we do have a factor. And the key thing is this would be x to the third plus 7x squared plus 4x plus 2. That's what it would be. If you're getting that, awesome. You should do fine on the practice problems. Practice will indeed make perfect, so try them out, check your answers, and enjoy synthetic division, everybody.